So steeper lines show greater risk, so it's more sensitive than the labor. So what are the advantages of sensitivity analysis? Well, one, it identifies the variables that are most critical to the analysis. In other words, because you're changing the variables one at a time, in other words, you're always keeping the base case assumptions the same, and you're just changing one variable at a time, that allows you to identify the variables that are really driving the profitability of this capital budgeting decision. So you know if you change one variable by 10% or 20% and the NPV doesn't change very much, then you don't really need to worry about that as a manager. The gods are not with me today. And secondly, it tells you what variables you can safely ignore. So it gives you some information about what to focus on and what can be safely ignored. You can also use it to provide some basic break-even information. You can see by the line here, that the volume breaks even about minus 19% or so. So you could be up to 19% below in volume and still have a positive NPV and a positive NPV. Below 19%, it quickly turns into a negative NPV. So the disadvantages: it does not consider the amount by which input variables could actually change. So in the real world, we seldom know. Maybe there's maybe some variables that could be much more there may be a much greater range of change for some variables than others. Does not consider any interaction among the input variables. What does that mean?
I mean, when you look at labor costs and volume, when you think about that logically, if your volume increases, probably your labor costs also decrease. There should be a relationship.
That's right. So if your volume is 30% higher than what you thought it was going to be, almost certainly you will have had to hire some more staff as well. So it does not consider the interaction between each of the variables. You really change because you're changing one variable at a time. And second, the final is that it provides no quantitative measure of risk. There's no standard deviation, for example, that makes it easy to make a judgment about risk. So the second method we're going to talk about today is scenario analysis. And essentially, in the simplest version of scenario analysis, we talk about three possible outcomes: the worst case, the most likely case, and the best case. The most likely case is your base case. It's the one that you think is going to happen. And so in this method, essentially, managers are interested in knowing if everything bad happens, if everything that can go wrong with this project, if they all happen at the same time, what happens to the profitability of this project? On the other hand, if the stars align and everything good that can happen does in fact happen, what might be the best profitability under that circumstance? So it really provides a range of a maximum and a minimum and a most likely kind of estimate. And again, you can use that to generate a quantitative measure of risk. So here's a simple example. We've got a base case of 5,000, a volume of 5,000, which we talked about a minute ago, and labor costs of $100,000. So our base case is a net present value of $117,000. Our worst case scenario is that volume is in fact only 4,000 scans, and labor costs are a lot higher than what we thought they were going to be, 120,000. On the other hand, if the stars align favorably, we could have as many as 6,000 scans and labor costs as low as $80,000. And then we can calculate the net present value under those three scenarios. We can then calculate the expected net present value, which is 117,000, because it's equally distributed, because there's 1,000 below and 1,000 above, and the probability is equally distributed, and the labor costs are equally distributed. If they were not, then the expected would not equal the most likely. And then we calculate the standard deviation and then a coefficient of variation, 1.2. So in this circumstance, this tells managers the most worst thing that can happen, the best thing that can happen, and the most likely. Managers will recognize that the probability of minus 86,000, the worst case scenario, the probability of everything bad happening all at the same time is low. And similarly, the probability of everything good happening at the same time is low. But it gives them a range on which to assess the risk, that this project has an NPV probably between 0 and 200,000, something like that. So the advantage of scenario analysis, it does consider more than one variable at a time, because you can specify all the bad case and variables that you want. You can specify all the good case variables that you want. Provides information about the worst possible results, and there's a quantitative measure of risk that you can derive. Disadvantages of scenario analysis, we've got 3 here: best case, worst case, most likely. In the real world, there's an infinite number of possibilities. Amy?
How do you interpret the coefficient variation?
It is the amount of risk per unit of return. So the larger the number, the more risky is the project.
Is there like a certain range that's usually fall
No, and we'll talk more about that when you do the case. But essentially, you want to look at the coefficient of variation for the average project in the organization, and you compare it to the coefficient of variation for this project. If it's greater than the average, then it's a riskier than average project.
So is the unit of, it was the risk per unit, what was the interpretation again?
Risk per unit of return. And again, all that is just from Chapter 4. The other disadvantage is that it forces all best case, worst case values together, which are extremely unlikely. It really does give you the worst, absolute worst, and absolute best possibilities. So why is it important for managers to know the worst possible outcome? And secondly, does the scale of an investment affect its risk? You can actually use the second question to answer the first. Why would you as a manager want to know the worst possible outcome? Robbie?
Because even if it's highly unlikely, if you can absorb that, then you're probably still fine. But if that outcome is going to ruin your business, then you're probably not, you may be less likely to make that investment, even if it's a small chance to occur.
Precisely. That is the exact reason. Different projects have got different levels of financial fallout. Some programs, some capital investments, a lot of organizations can easily absorb. If it doesn't work, it doesn't work, it doesn't matter. But some projects are so big that if they fail or succeed, can threaten the ongoing viability of the organization. So, for example, is there a difference in a $10,000 investment in MHA stock riskier than a $1,000 investment? Or let me put it in personally. Is it, how risky would this investment be to you today versus a year from today, when you're all taxpayers? Can all of you easily absorb a $10,000 loss today? Probably not. Probably not. For some of you, 5 years from now, $10,000 will be how much you spend on lattes per year, and you won't blink. So this... You think I exaggerate. I've had some lunches and dinners with MHA graduates from 5-7 years ago, and they've been very nice dinners, let me tell you that. More than I can afford. So the answer is the scale does affect the risk of investment. I mean, joking aside, a $1,000 loss today to you could be actually worse than a $10,000 loss 10 years from now. So the ability to absorb the size of the investment is a relevant factor for risk assessment. Finally, Monte Carlo simulation. Again, this used to be a sort of a very advanced analytical tool. You need a huge mainframe computer to do it now. There's lots of any Excel spreadsheet there are add-in packages for it. It's easy to do. The advantage of it is that what it involves is that it essentially is you specify probabilities of different things happening, and it generates continuous probability distributions. So what it does is it calculates net cash flows and so on the basis of input values chosen. So if you say the maximum volume is going to be this, and the lowest volume is going to be that, then the maximum revenue per scan is going to be this, the lowest is going to be that, and then essentially what it does is it draws numbers at random up to 5,000 times, and it constructs a probability distribution of a net present value of the project under all these different scenarios. And the great thing about it is that well, let me go through what the advantages are. So what it does is it constructs a probability distribution. So it tells you that the expected value, NPV there, which is our $117,000, but it also tells you what does it look like, how risky is it around that expected net present value. So there again, you construct measures of skewness and distribution with this kind of thing as well. And as I said a minute ago, this technique has gained a lot more popularity as more accountable care organizations, for example, start to have lives, thousands of lives, and health plans and providers are using Monte Carlo to simulate utilization and the risk of different utilization levels. So the advantages are it reflects it has all the different inputs, it has all the different probabilities, and all the interactions between the variables is taken into account. So all possible combinations of permutations of the input variables are considered. The disadvantage is that it's really difficult to know what some of the probabilities are going to be. The results look very precise, but they're only good as the validity of the input data. So again, one of the reasons why this is taking off in popularity is that if providers and health plans that have got a lot of historical utilization data have got very good estimates of the probabilities of these different kinds of utilization. For example, if you've got 1,000 people covered lives and 100 of them are 65 to 85 years of age and 400 are 45 to 65 and so on, and they've got the gender, they can generate distributions of utilization with a lot of accuracy.